Hey y'all. Welcome to Adding and Subtracting Decimals, late night 10:24 p.m. edition. This is my life now. I have a baby. So who sleeps? Nobody. Um I hope y'all are having a great day. Let's check this out. What do you notice? What do you wonder? I wonder why it's blank. Oh, let's study the following image. Okay. So it looks like kind of like a part whole diagram. We also have some hearts in there. We got a blue heart and a green heart in the whole. We have a blue heart as one part and a green heart as one part. Sounds like a poem of some sort. Let's move on. Let's see what's happening here. Oh, so it looks like what they want you to see is once again we can use strip diagrams to represent addition subtraction problems. And now we can even use them to represent things like decimals. All right, so I am, for some reason, redrawing exactly what you're looking at on your screen right now. So there is 7 and 57 hundredths. Remember, know how to read your decimals. If you can read a decimal, it makes everything about using decimals easier. If you're saying 7.57, that is not how you read decimals. That doesn't really tell you what the smallest place value is. If you say it in word form, 7 and 57 hundredths, boom, you know what your smallest place value is because you just said it. So remember, if you can say the numbers correctly, then you are getting your place value, so keep working on it. So basically what we're looking at here, to me, it looks like we could either make this some kind of unknown value problem, but I don't think we're doing that yet. Or we could just make it like 10 minus one of our parts equals the question mark, right? Um, and so we're back to kind of looking at these like we did in fourth grade, except for instead of whole numbers, we're looking at decimals. But there's a question mark. Could they have used a letter? Absolutely. Could you have done it if they used a letter? Also, absolutely. So what model is being represented? I think we just figured it out. If we took 10, our whole, and took away 7 and 57 hundredths, that should give us this missing value right here. So remember, if I wanted to make this into like an algebraic expression, instead of using the question mark, I could just use like x. And then we could say 10 minus 7 and 57 hundredths is equal to x. And then we'd be looking at a algebraic equation, but they're probably not going to do that. Nope, they didn't. They just made an expression. 10 minus 7 and 57 hundredths. So looks like they want to show us what that looks like. So they took 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 holes. Remember, these are holes now. These are holes now. One hole, right? This is one hole. It used to be 100. Now it is 1. Such a difference. But now think about it. It's still 100 of something. It's just 100 hundredths, right? So this is a dollar. A hundredth is like a penny. A tenth is like a dime. 10 pennies make a dime. 10 hundredths make a tenth. 10 tenths make a whole. So, same idea. All right. So now, just like we did yesterday, we're going to cross out 7 hundredths, 5 tenths, and 7 wholes. Remember, that's because I have 7 hundredths, 5 tenths, and 7 ones or whole numbers, right? So what they're going to do, we're going to have to regroup. So they're going to break up one of those, I'm sure. And that's what they did. So they broke up one whole into 10 tenths and then broke up one of those tenths into 10 hundredths. So we did all the regrouping. Let's come back to the next video and see what that looks like compared to the algorithm, which always works.